Namaste, student. And today we are going to see a new chapter called Permutation and Combination. Okay, yeah. At the end of this session, you will be able to define the fundamental principle of counting, permutation, and factorial notation. Identify the number of permutations when all the objects are distinct. Calculate the factorial notation. Before getting into the chapter, let us see one activity. That is, you are having a three water bottles and two lunch box. Okay, what are the possibilities? You can take a lunch along with the water to a school. The possibilities are, you will take a first water bottle green color with green color box, or you can take green color water bottle with blue color box. This is the two way. Or I can take a red color water bottle with green color lunch box, or red color water bottle with blue color lunch box, and that green bottle with green color lunch box, or green bottle with blue color lunch box. So these are the possible way you can take a lunch box along with the water to the school. So how many ways we are having it? We are having totally 6 ways, right? Fine. Now this is nothing but the fundamental principle of counting. If an event can occur in m different ways, following with another event can occur in n different ways, then the total number of occurrence of the event in the given order is m cross n, or it is m into n. How many water bottle you have taken? 3 water bottles. Okay, and how many lunch box you have taken? 2 lunch box. That is 3 twos are 3 twos are 6. So totally in 6 ways you can take the lunch box along with the water bottle to the school. Okay, this we call it as an fundamental principle of counting. Now we'll see an example on this one. Example 1. Find the number of 4-letter words with or without meaning. It can be the, if you are framing a word, it should have a meaning or it cannot have a meaning, which can be formed out of the letters of the word rose. So you have to take the letters from the word rose. Okay, now I am taking the letters R, O, S, E, where the repetition of the letters is not allowed. Here the repetition is not allowed. We have to be careful with this. Okay, yes. Now we are going to frame a 4-letter words. For that I am going to make a box. 4-letter, so I am going to make 4 box. Okay, in the first option, that is in a first box, we have a 4 options. That is, either you can place R, or you can place O, or you can take S, or you can take E. Suppose if I placed O over in this box, then how many letters are left? 3 letters. One is R, another one is S, another one is 3. Among these 3, I had placed 3 in this place. So the remaining letters are R, S. Now I am having only 2 letters to place it in this third place. Here I am placing a S. So how many left over? Only R. So the permutation of this, not permutation, the arrangement is nothing but in a first box, how many letters are possible? 4 letters. In the second box, how many letters are possible? 3. And in the third box, we have only 2 letters. And in the fourth box, we have only 1 letter. So 4 into 3 into 1 is 24. Therefore, the number of ways the 4-letter word can be formed is 24 ways. Have you understand clearly this one? Yeah. Let us see another example. Given 4 flags of different colors. Here they given different colors. For that I will take that is I'm going to show this is one color flag, another one is blue color, another one is green color, another one I'm taking purple. Yeah, this is the 4 color flags. Okay, how many different signals can be generated if a signal requires the uses of 2 colors one below the other? That means you can show a signal with only any 2 flags. You have to take only 2 flags. That means, for example, if I'm taking a purple, I can take a red along with this. Like this, how many samples or how many different signals it can be displayed? The same way, that is, I will explain you. That is, in the first place, I have 4 color options. One is I'm having a red color flag, and then I'm having a blue color flag, and then I'm having a green color flag, and finally I'm having 4 that purple color. So totally I have a 4 colors to be placed in this one. Another flag is, once I placed one color flag over here, if I'm going to place, for example, if I placed a purple over here, then what is the remaining colors left out? A red color left out, and the one is blue color, another one is green color. So how many flags are there here? 3 colors. If I'm placing a green color over here, now my flag signal is purple with green. So what are the ways? In the first place, I have a 4 color option. In the second place, I have a 3 color options. So totally we have 12 ways. In a 12 ways, we can arrange the 4 colors flag to show the signals. Okay, fine. Example 3. How many 2-digit even number? You have to be careful. 2-digit even number can be formed from the digits 1, 2, 3, 4, 5. Now the digits are 1, 2, 3, 4, 5. So totally we have a 5 numbers. Okay. Now we are going to frame a 2-digit. So I'm going to represent it as ones and tens. Okay. Yeah. This is ones place and this is tens place. Now in the tens place, I have a option of how many numbers? 5 numbers. Either I can place 1 or 2 or 3, 4, 5. I have a how many options? 5 numbers are in my hand to be placed in this tens place. In ones place, it should be a even number. So if it is a even number, the ones place should have either 2 or 4. So in ones place, I have only 2 options. So how many ways we can form 2-digit number? 5 into 2. 5 into 2 is 10. 10 ways. Therefore, the number of ways to form a 2-digit even number is 10 ways. And next, example 4. I have to be careful in this question. Find the number of different signals that can be generated by arranging at least 2 flags in order to one below the other. That is, on a vertical staff, if 5 different flags are available. Here also we are having a 5 different color flags to get the thing. Okay, now we can form a at least 2 flags. What is the at least 2 flags means? I told you already, greater than or equal to 2. So your flags can be two, that is 2 signal flags, 3 signal, 4 and 5 signals. For that is, first I am taking only 2 flags at a time. That is 2 flag signals. Okay, yeah, FLA, sorry, FLAG. Yeah, 2 flag signals. So what are the possibilities I can have? One is, for example, I will draw it in a small box to show this. So like this we can take. In a first place, I can have 5 flags. In the second, I have a how many options? 4. So if I am going to show 2 flags, my possibility is 5 into 4. That is 20. That's it. And now I'm going to get 3 flags. 3 flags. Okay. Yeah. That means first flag, second one, third one. In this, how many possibilities are there? In the first place, I have a 5 flag colors. In the second place, I have a 4 colors. In the third place, I have a 3 colors. That means 5 into 4 into, 4 into 3. Okay, yeah. 5 fours are 20. 20 into 3 is 60. 60 ways. And now, greater or equal to 2. Like that, you have to go for 4 flags. 4 flags. For 4 flags, how many ways? 5 into 4 into 3 into 2. Then you will get 120 ways. If I am having 5 flags together, that is 5 flags together. So how many possibles are there? 5 into 4 into 3 into 2 into 1. Totally you will have 120 flags. Now they are asking all the signals, all different signals. That means you have to add all this sample ways. One is 20 plus 60 plus 120 plus 120. So 120, 120 and 60 will become 300. Now 320 ways. Okay. Yes, you have to be careful. So far we saw only one type of flags. That is two flags at a time, 3 flags at a time. But here you can form 2 flags, 2 color flags, 3 color flags, 4 and 5 color flags, because they are given the word at least 2. At least means greater than or equal to 2. Now we'll see an exercise sum. First one, how many 3-digit number can be formed from the digits 1, 2, 3, 4 and 5? Assuming that the first subdivision is repetition of the digit is allowed. Okay, yeah. Now we are going to form 3-digit number. So to get 3-digit number, I am placing ones place and I am taking tens place and then 100 place. Here the repetition is allowed, right? So in the 100 place, I have 1, 2, 3, 4 and 5. 5 numbers. In the tens place also, I am having 5 numbers, because the first subdivision is repetition of the digit is allowed. In the ones place also, I have a 5. So the total number of ways is 5 into 5 into 5. 5 into 5 into 5 is what? 125 ways. Okay, fine. This is first subdivision. and second subdivision. In the second subdivision, they are given repetition of the digit is not allowed. Repetition of the digit is not allowed. Okay? Yeah. Here also I am going to take ones place, tens place and hundred place. In hundred place, I have 1, 2, 3, 4 and 5. So 5 possibilities are there. If I place 5 over here, I have only 4 numbers. 1, 2, 3, 4. If I place 2 over here, I am having only 3 numbers. 1, 3 and then 4. So the number of ways are here 5 into 4 into 3. 5 into 4 into 3 is what? 60. So 60 ways. So this is the nice example for repetition of digit is allowed and repetition of digit is not allowed. Okay. Next, question number 2. How many 3-digit even number can be formed from the digits 1, 2, 3, 4, 5, 6. If the digits can be repeated, here the digits can be repeated. Okay, yeah. Now I am taking the blocks ones place and then tens place and next one is 100 place. Okay, yeah. Now the digits are 1 to 6. So I can take the digits 1, 2, 3, 4, 5, 6. Okay, yes. Here the digits can be repeated. So in the tens place also I have an option 1, 2, 3, 4, 5, 6. Now in the ones place there is only 3 numbers 2, 4, 6 because I need the 3-digit even number. Therefore, the number of ways are 6 into 6 into 3. 6 into 6 into 3 is 108 ways. Okay? Yeah. It's a very interesting and easy chapter. Okay. How many 4-letter code can be formed using first 10 letters of the English alphabets? If no repetition, no letter can be repeated. If no letter can be repeated, that is, no other letters are going to be repeated. Okay. Yeah. 4-letter word. So, first place, second place, third place and fourth place. Yeah. Here I have a option of 10 letters. I have 10 letters to be placed in this first place. So 10. If any of one letter is placed, at the first 10 letter means A to J, right? Yes. In this, if I placed here E, so how many letters are left over? 9. In the second place, I have a 9 letters to be placed. Here if I am using a J, then I have a 8 letters to be placed over there. Here I am placing a F. Then I will have a 7 letters to be placed over here. Therefore, the number of ways a 4-letter code can be formed is 10 into 9 into 8 into 7. So, you will get 5040. Okay. Next, question number 4. How many 5-digit telephone number can be constructed using the digit 0 to 9? So, 0 to 9 is given, right? 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, totally we have a 10 numbers. Okay. Yes, we are going to frame 5-digit number. So 1, 2, 3, 4, 5. 5 digit numbers you are going to frame. But they are given the clue, the starting with 67. So it is sure that the first place should be 6 and second place should be 7. Okay, therefore the possible in the first place is one number, and here it is also one number. Among the 10 numbers, the two numbers are already used. So in this place I have a option of 8 numbers, that is 0 1 2 3 4 5 8 9. And in the next place I have only 7 numbers to be placed, and in the last I have only 6 numbers to be placed. So the number of ways is 1 into 1 into 8 into 7 into 6. While you are multiplying, you will get 336 ways. Okay, yeah. And next one is question number 5. A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? A coin is tossed how many times? 3 times. So this is the first time, and this box is used to denote the second time, and this box is used to denote third time. Okay, yeah. In the first time I have an option of head or tail, and here also I am having head, tail, and here also I am having head, tail. Therefore 2 into 2 into 2, that is 8 ways. Okay, fine. Now, given 5 flags of different colors, how many different signals can be generated if each signals requires the uses of 2 flags, one below the other? The same way we did it in an example, right? This is the first flag, and the one is the second flag. We have totally 5 flags. So in a first place I have a 5 flags, that is 5 options are there. In the second place I have only 4 options. Therefore 5 into 4. 5 into 4 is 20 ways. Okay.